In this video, we are going to go over some of the problems found under Goal 5 in your Unit 13 Acids and Bases unit. So let's first start with question number 36. Now in question number 36, they give us a formula. So Kw is equal to 1 times 10 to the minus 14, and that is equal to the concentration of the hydrogen ion times the concentration of the hydroxide ion. So let's look at the first problem. So on the first line of that table, it gives us the hydrogen ion concentration. So I'm going to put that into my formula. So you see the only thing we don't know is the hydroxide ion concentration. So this is like your X, this is your unknown. So I am going to divide each side by 7.67. This will cancel and I'll be left with the hydroxide equaling, so I'll put this into my calculator, 1 exponent button negative 14 divided by 7.67 exponent button negative 9. And I get 1.30 times 10 to the minus 6. So there's my number. So you could rearrange your equation before you put everything into it. And so it would be OH minus is equal to 1 times 10 to the minus 14 divided the hydrogen ion concentration. And you also could switch it around. So in some of the problems, they give us the hydroxide. So I would just take the 1 times 10 to the minus 14 divided by that hydroxide ion concentration. So on all of these acid-base problems in Goal 5, you need to use your equation. So these equations will be given to you on the test. You don't need to memorize them, but you do need to know how to use them. So make sure you know how to write down the equation and then plug in what is given to you and then find the unknown. But this is how you do that whole chart for question number 36, is using this equation right here. Okay, let's look at the next problem set. Now on this problem set, we have a box that has a whole bunch of formulas in it. So again, these are all your formulas that you're going to use. You do not have to have them memorized, but you just need to know how to use them. Find a formula to help you out, plug in the knowns, and then find the unknowns. So let's look at the very first line. So I designed this table so the first 4 you can do in your head. And use your calculator just to make sure you're doing it right so that you can learn how to do it in your head. The last 4 lines of this table, you will have to use a calculator. They have what I call ugly numbers, so you can't do it in your head, you have to use a calculator. But hopefully, working through the problems, the first 4 lines, that will help you figure out the last 4 lines. All right, let's look at this first line. So the first line, it's given to us the pH is 3. So knowing the pH is 3, I know that this is an acid. And that is because it's less than 7. So lower than 7, that means it's an acid. All right, so the next line is that hydrogen ion concentration. So for the hydrogen ion concentration, I am going to use this second equation. So the hydrogen ion concentration is equal to 10 to the minus pH. So let's plug in what we know. So I know that the pH is 3, so I'm going to plug it in. Now if you were to press enter on your calculator, you would get this number, 0.001. So that is perfectly correct. You also could write it like this, 1 times 10 to the minus 3. So notice what happens. So this 3 becomes the negative exponent. So you can see how you can do it in your head. You just tack it on to a 10 to the negative pH. All right, let's look at this next one. So the pOH. So for this one, I'm going to use the formula pH plus pOH equals 14. Let me plug in what I know. So my pH is 3 plus my pOH, and it's equal to 14. So I'm going to get all my numbers on the same side. And I have 14 minus 3. So my pOH is 11. So notice that the pH and the pOH, they add up to 14 always. All right, we have one more to go. And for this one, there's a couple different ways that you can do it. So I'll show you both ways, and you can do whichever way you like, but I'm going to use this last equation. So I have my pOH, or excuse me, my OH is equal to the pOH is equal to 10 to the negative pOH. So I know what my pOH is. It's an 11. So I have 10 to the minus 11. So if you press enter, that would be the next thing, enter, you are going to get 1 times 10 to the minus 11. So that's our answer. Now see how you can do this in your head. This pOH becomes the negative exponent. So you can kind of do it in your head. There's another way to find that OH, and it would be the same way you found it in question number 36. So for this one, remember you can find the OH by taking 1 times 10 to the minus 14 divided by your hydrogen ion concentration. So you would have 1 times 10 to the minus 14 divided by 1 times 10 to the minus 3. And when you divide with your exponents, you actually subtract. So you're going to get 1 times 10 to the minus 11. So just another way to do it. It gives you the exact same answer, but there's a couple of different ways to approach these. So notice that you can do that whole first line just in your head, because you just take that exponent and make it the negative exponent there. And then this one, you subtract it from 14. And then you take this one and make it put it to that negative exponent. So again, you can do these in your head. Let's go ahead and do one where you have to use a calculator. And so I'm going to do the one that says the pOH is 5.44. Okay, so again, this is the third from the bottom. So our pOH is 5.44. I think I'm going to find my pH first, because that's kind of simple. Again, I'm going to use my pH plus pOH equals 14. And I know my pOH is 5.4. So my unknown is my pH. So get all the numbers on one side. So subtract each side by 5.44. And maybe you can do this in your head, but I like to use a calculator. I get 8.56. So that's my pH. So now that I know my pH, I can figure out if it's an acid or base. Remember, if it's an acid or base, always depends on the pH. So this is above 7, so this is a base. So again, 7 is neutral, below 7 is an acid, above 7 is a base. All right, let's look at our other ones here. So I'm going to do my hydrogen ion concentration. So for this one, I am going to use this equation right here. So write my formula. So the 10 to the minus pH. So I'm going to do 10 to the negative 8.56. And you need to press enter. So I do this by taking and putting in my calculator negative 8.56. And then I'm going to use that 10 to the X button. It should be on your log button. It's actually called the anti-log button, the 10 to the X button, because that's what we're doing. We're getting out of pH, which is on the logarithmic scale, and so we're going backwards. So that would be the anti-log button, or the 10 to the X button. So I am going to just press that, and I get as my hydrogen concentration 2.75 times 10 to the minus 9. So that's my answer. So again, these we can't do in our head, but the steps are all the same. All right, we have one more. We have our OH. Again, there's two different ways to do it. I think I'm just going to get it from this last equation. So OH is equal to 10 to the negative POH. So I have 10 to the negative 5.44. So I'm going to press enter. So don't leave it as a decimal number in the exponent. So again, I'm going to use that 10 to the X button. And I get as my hydroxide concentration 3.6 times 10 to the negative 6. So 3.6 times 10 to the negative 6. Again, you could also use the equation like you did in question number 36. So the one just right above, that Ka equation. So you still have that one at your disposal. So you would just take 1 times 10 to the negative 14 divided by the 2.65 times 10 to the negative 9th. So again, you can use like what you did in question 26, or excuse me, 36, to find that OH. Okay, let's look at some other ones that tend to give students some problems. Let's look at question number 38. So question number 38, it shows a weak acid and it's dissociating. So you do this problem just like question number 31. And there was a tutorial for Goal 4. You can go back and listen to it, or you can just look at what you did for question 31. This is done the exact same way. So once you find your hydrogen ion concentration, remember to write your Ka products over reactants, plug in what you know, solve for X, and that X is the hydrogen ion concentration. And then I'm just going to take the negative log of that. Let's now do question number, this is 39. So question number 39, it says, what is the pH of a 0.01 molar solution of hydrochloric acid? And hydrochloric acid is a strong acid. So remember, in strong acids, the reason why they're strong is because there's 100% dissociation. So on this one, at the start, I have a 0.01 concentration, and I don't have any of these. But then as soon as I put this in solution, my end concentration, this will be 0 because it's going to completely split apart. And these are both going to be 0.01. So again, this acid, it's together over here, but then over here, they're going to be completely split apart. So you can see that I have one colored in and one not colored in. And then over here, when it splits apart, I have one colored in and one not colored in. So you can see they're going to be equal concentrations. So whatever my starting concentration, it ends up being the concentration of the hydrogen ion. This is only for strong acids. So weak acids, you have to do what you did in question number 38, where you have to do your equilibrium constant for acids. So for this one, pH is determined by the hydrogen ion concentration. So my H plus is equal to 0.01. And so when I find my pH, I have the negative log of 0.01. And I actually can do this in my head. So this is 1 times 10 to the minus 2. So my pH would be that exponent, so that 2. So my pH is 2. And if you have a hard time figuring that out in your head, you can always use your calculator. So just take the log, use your log button, LOG, 0.01.